Today we're going to talk about Newton's second law of motion, which is also known as the law of acceleration. To talk about that, we're going to learn about this formula called force equals mass times acceleration. That's F equals m times a. We'll talk about acceleration due to gravity and terminal velocity. So to talk about this Newton's second law of motion, let's go to this website, and I'm just going to read it so that you can see it as we go down. Newton's second law of motion, acceleration, or that means speeding up. Acceleration is not moving, it's actually going from a slower speed to a faster speed, or a faster speed to a slower speed. So let's read this. Acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. So if you're going to push a bowling ball, you've got to push that really hard to get it to move, whereas a ping pong ball you may not have to push as hard. Everyone unconsciously knows the second law. Everyone knows that a heavier object requires more force to move than the same distance as a lighter object. So if you look at this little test tube kicking a brick wall, he's saying, ouch. He's not going to get the brick wall to move very easily. But if you use the same force to kick something smaller with less mass, like a soccer ball, you can kick it. Up here, this guy is saying more mass means more force needed to accelerate. And that's really the second law. More mass means more force needed to accelerate. So the second law gives us an exact relationship between force, mass, and acceleration. It can be expressed as a mathematical equation: force equals mass times acceleration. So to practice, here's an example of the second law. How much force does this guy need to push the car? The car weighs or has a mass of 1,000 kilograms, and he's going to cause it to accelerate at a rate of 0.05 meters per second, or we just say meters per second squared. So you would plug it into this formula. 1,000 kilograms is the mass times 0.05. So let's do that on a calculator. 1,000 times 0.05, and we get 50 newtons of force must be applied in order to get this car to accelerate by 0.05 meters per second squared. So using our STD chart, we can manipulate this equation any way we need to. For example, if we know that force equals mass times acceleration, well, if we need to find the mass, we just take mass equals force divided by acceleration. And if we need to find out the acceleration, we take the force and divide it by the mass. So let's talk about acceleration due to gravity. That's if let's say you jump out of a plane and you're falling. So this is only when something is falling does this work, and it has to be free falling, not being thrown. If you throw something out of a plane, well, that changes things. But if you just free fall out of a plane, or free fall from a cliff, or if you roll a ball off a desk or something like that, then the acceleration due to gravity is a constant. You speed up at a constant rate. On Earth, gravity causes you to accelerate at 9.8 meters per second squared. And yes, that number must be memorized. 9.8 meters per second squared is the acceleration due to gravity. So if we're talking about the force of something that falling from a plane or something, we always say force equals mass times acceleration, or force equals mass times 9.8 meters per second squared. Okay, so now let's talk about terminal velocity. When you're falling out of the plane, we just said that gravity is going to pull down on you at 9.8 meters per second squared. You're going to accelerate at that rate until you hit what we call terminal velocity. And that is because on Earth there is air, so there are air molecules, gas molecules in the air, that are going to be pushing back on you as you fall. That's the wind that you feel. You're going to be having air pressure or air resistance pushing back on you. And at a certain point, the air resistance is going to be equal to the amount that gravity can pull down on you. And so when gravity can't pull down any faster on you, then the air pressure or air resistance is pushing back on you. That's called the terminal velocity. So if we take this ball, for example, then as it falls, gravity is pulling down, and you're speeding up at 9.8 meters per second squared. At the same time, air resistance is pushing up on you. And so when gravity and air resistance reach a point where gravity just can't pull any harder because air resistance is pushing back too much on you, then you stay at that same speed. You won't accelerate anymore, you just keep falling at that same rate. And that's called terminal velocity. So this is Newton's second law, the law of acceleration. Force equals mass times acceleration.